All right, so this video here is just going to be a way to help you guys all out with the reading. The reading is kind of long, so if you're somebody who prefers to have somebody read it out loud to them and have somebody talk it out while it's all happening, that's what the purpose of this video is going to be. So when we're looking at plate tectonic boundaries, what does that mean? That means it's really right at the edge of two plates meeting. And there's certain ways that these plates are going to react. So in the beginning of the reading, it starts off like this. Many of the world's most active volcanoes are located around the edges of the Pacific Ocean. People refer to this area as the Ring of Fire, shown on the map below. About 90% of the world's earthquakes also occur in this region. These geological processes are caused by interactions between the plates and the plate boundaries that are surrounded in the Ring of Fire. So why are there so many volcanoes and earthquakes at plate boundaries? So if we look here, what is happening is this is the Ring of Fire. And if we look, though, some of these volcanoes themselves actually might be underwater, but also some of them might be on land. And what you're also seeing is these are where all of the earthquakes, or a ton of earthquakes, occur. Famously, California has earthquakes. Alaska has earthquakes. And if we look over here in Japan, a lot of this activity is happening at the bottom of the ocean floor or on land. But really the connection is why are there so many volcanoes and earthquakes that happen right where two plates will meet? So the reading itself we're going to look at how different plates move and what happens when they actually interact with each other. So the Earth's lithosphere is broken into plates they're always in motion. So the tectonic plates are always in motion. The plates may be moving apart, or moving towards each other, or moving past one another. Over geologic time, it's important in geologic process, such as the formation of mountain ranges, earthquakes, and volcanoes, take place along the boundaries where the lithosphere meets. So if we look, you have a convergent plate boundary, so we have two plates here. We have a divergent one where two plates are meeting here and here, and then we have another one here and here where two plates are meeting. So plates that move away from each other. So geologists call a region where two plates are spreading apart as a divergent plate boundary. So if we look here, right here on the bottom of the ocean floor is where they're kind of referencing, is that is where you are going to find two plates moving apart. As the plates move apart, the lithosphere thins and lava erupts into the surface. New lithosphere forms as the lava cools and solidifies to form igneous rock. So a lot of where this actually happens is on the ocean floor. So when the plates move apart, brand new magma and lava comes up and it cools to form brand new ocean floor. Oftentimes, divergent plate boundaries are on the ocean floor. Large underwater volcano mountain chains that form along divergent plate boundaries are called mid-ocean ridges. So there is a ton of underwater volcanoes. So one of the largest mid-ocean ridges is between the North American and Eurasian plates in the middle of the Atlantic Ocean. So when the plates move away from each other at the other divergent plate boundaries, a rift valley forms. A rift valley is a long depression between mountains that forms due to the spreading plates. So what does that mean? That means what you're having is there's this area, this almost like flat area, as these two mountains are moving, like these mountain chains are moving apart from one another. In 2005, a large earthquake happened near Lake Tanganyika in Africa. The earthquake was caused by divergent plate motion, where two sections of the African plate are moving away from each other. Now, so we just covered what can happen if two plates move apart from each other. So you're going to get a lot of this, especially on the bottom of the ocean floor. You're going to get mid-ocean ridges. So those underwater volcanoes that are forming in brand new ocean floor is basically forming at this location here. And then if we look here, this is where you would see the oldest ocean floors right on the coast of the United States and the coast of Africa. So that's the oldest ocean floor. Because the newest stuff is formed right here in the middle. And as it gets older, it gets pushed out. Here, though, on land, you can actually see an example of what happens when you have two plate tectonics or two plates that are moving apart, where we have large earthquakes happening, but you have this valley in between these mountains. And that's sort of what we are seeing here. So next we go to the ones where plates moving towards each other. So there's a lot that can happen here. So geologists call this, where two plates are moving towards each other, a convergent plate boundary. So the geological process that happens along a convergent plate boundary depends on the type of lithosphere at the edge of the colliding plates. Now, Earth's lithosphere, which includes the crust and solid upper mantle, carries a thickness and density over the Earth's surface. The crust that makes up the ocean is generally thinner than the crust that makes up the continents. So, really, what all of this is going to be telling you is this: we have two types of crust. You have oceanic and you have continental. Continental stuff is thick, but it's much thicker than the oceanic stuff. The oceanic stuff, if the two are going to collide, oceanic is going to lose every time. It's going to get pushed right underneath this much larger, thicker continental crust. So despite being thinner, oceanic lithosphere crust is denser than the continental because the crust is made up of denser rock. And as we know, more dense things sink, go underneath, less dense things float, go over the top. So when two plates move towards each other, the denser plate sinks below the less dense plate. So when continental and oceanic move towards each other, the denser oceanic stuff sinks into the mantle and is destroyed. The same process also happens when two oceanic lithospheric plates move towards each other. The denser plate sinks underneath the less dense plate. This process is called a subduction. And this is where you're going to see these huge trenches forming. So at subduction zones, right? So there's this space here as one plate is being pushed underneath the other. The Marianas Trench is famous for this. It's a huge trench at the bottom of the ocean floor. And it's because there's two oceanic plates hitting each other, and one gets pushed way underneath the other, and it creates a trench. So a trench is a deep, narrow depression on the sea floor. At a convergent plate boundary where subduction is occurring, a volcano will form. Now, that's a lot to take in for a second. So let's kind of break that down. So on the bottom of an ocean floor, right, this is happening, you are going to see a trench. Now, if this happens though on land, we are going to get a volcano forming. So why is that? All of this stuff down here, this used to be crust, right? It's going to get melted. And it's going to get melted and it's going to turn back into this orange, gooey magma. However, there's nowhere for it to go. Looks like there's already a lot of space already filled up. So if we're going to melt rock and make more magma, it has nowhere else to go. So usually what will happen is it breaks through the crust and starts forming volcanoes all over the place. And So at a convergent plate boundary where subduction is occurring, volcanoes form on the surface of the overlying lithospheric plate. The volcanoes that form at a convergent plate boundary where typical continental and oceanic move towards each other are typically stratovolcanoes. So large volcanoes that erupt violently, more of a gassy magma. So the volcanic mountains along the western coast of South America formed by subduction. So if we look, volcanic mountains are along, that was Chile. So when oceanic lithosphere of Pacific plate subducted below the continental plate of South America. Subduction formed the Peru-Chile Trench on the ocean floor along this boundary. The subduction is also happening in the Pacific Northwest of the United States. So what's cool about this, if we look at the trench, right? If we go ahead and we just go here, Earth, and if you open up Google Earth and they're talking about this trench, right? You can see the trench on Google Earth. So wait for it to load. And if I just search up Chile, and it's going to take us there, you can see the trench along the entire thing. This whole part here, see how it is really, really dark? It's all because of a trench. So this trench is formed on the bottom of the ocean floor. You can even start to see some underwater mountains over here, but this massive trench is because this oceanic crust is getting pushed into the continent and it's going underneath. But in this case, it's happening here out in the middle of the ocean. So let's keep going with our reading. So, plates that move past one another. So geologists call this region where two plates move past each other a transform plate boundary. Here, lithosphere is either created nor destroyed. So we're not getting new crust made. So there is no magma or mantle coming up. None of that. Here, earthquakes are the most common at this type of transform boundary. So what they do is they actually slip past one another. So a transform plate boundary exists on the western edge of California, as most famously known by many of you all. If you've watched the movie San Andreas, it's because the San Andreas plate boundary, or fault is what they kind of refer to it as. So a transform plate boundary exists along the western edge of California. The boundary is between the part of the Pacific plate and the part of the North American plate. Plate motion causes many earthquakes along this boundary, and two powerful earthquakes happened along this plate boundary near San Francisco in 1906 and 1989. These earthquakes lasted less than a minute, but the ground shaking and related natural disasters caused heavy damage to the city. So what you're seeing is when these two plates finally slip and move past one another, that's when they release a bunch of energy, causing the entire ground to shake. All right, last but not least, most earthquakes and volcanoes occur along plate boundaries, but sometimes they form elsewhere. For example, volcanoes form each Hawaiian island. Lava from the eruption over hundreds and thousands of years built up the islands, yet the Hawaiian Islands are located far from any plate boundary. Hawaii, a large island at the southern end of the island chain, is the one of those islands that still has an active volcano. Volcanoes that formed in the island are called shield volcanoes. They are typically large and broad-shaped. The volcanoes released swift-moving lava because of the less gassy magma. These volcanoes tend to have less explosive eruptions than other types of volcanoes. People can often safely walk near an erupting volcano. So, a new island is called Lohi, has begun to form beneath the ocean of the southeast of the island of Hawaii. But don't start making vacation plans to visit just yet. Scientists predict that it will rise above the ocean surface in about 1 million years. One argument about the Hawaiian island chain form suggests that molten material in a region called the hotspot rose to the surface from the deep mantle. According to this argument, movement of the Pacific plate carried each of the islands towards the northwest, away from the hotspot. Other arguments are based on the properties of plates. For example, volcanoes you might find thin or cracked. So this is just, if you want to read more about the massive nuclear disaster that happened in Japan, and really that this earthquake started on the bottom of the ocean floor. So really there's 3 ways the plates move, right? So either they are going to move apart, divergent, and this usually happens on the bottom of the ocean floor. So you're going to get these mountains and mid-ocean ridges on the bottom of the ocean floor. Or on land where you get like big valleys, or here you have 2 plates coming together. So when this happens, usually one plate gets pushed underneath the other. And then that's where you're going to have volcanoes and things forming. Now, if you have 2 plates that come together and they go straight up, that can also form mountains. And then if we look here, we have plates that slip past each other. That is a transform plate boundary. So those are the 3 main types. And what happens at transform is earthquakes. Nothing new is made. No new plates are made. Just earthquakes. So thanks for watching.